Welcome to Thinking Mathematically's Chapter 10, Geometry, and we are continuing with Section 10.3, Polygons, Perimeters, and Tessellations. The objectives: name certain polygons according to the number of sides, recognize the characteristics of certain quadrilaterals, solve problems involving a polygon's perimeter, find the sum of the measures of a polygon's angles, and understand tessellations and their angle requirements. A polygon is any closed shape in the plane formed by three or more line segments that intersect only at their endpoints. A regular polygon has sides that all have the same length and angles all the same measure, and the perimeter of a polygon would be the sum of the lengths of its sides. This slide shows the various regular polygons. A triangle has three sides, a quadrilateral has four sides, pentagon 5 sides, hexagon 6 sides, heptagon 7 sides, and octagon 8 sides. There's other polygons as well, but these are the most common ones. These are regular polygons. This chart represents different types of quadrilaterals. Remember, quad means four, so these are polygons with four sides. A parallelogram is a quadrilateral where the opposite sides are equal and parallel. Opposite angles have the same measures, and you can see that in the representation on the right. A rhombus is kind of like a square that's leaning. It's a parallelogram with all sides having equal lengths and opposite angles are equal. Rectangle, parallelogram with four right angles. Because a rectangle is a parallelogram, opposite sides are parallel and have the same measure. A square is a rectangle with all sides equal and each angle measures 90 degrees. The square is a regular quadrilateral because all of the sides are equal. Trapezoid, a quadrilateral with exactly one pair of parallel sides. The other two sides are not parallel. This is where it gets fun, or some people think it's fun. These are some practical applications of polygons. This is an example of perimeter. Fencing costs $5.25 per foot. We want to find the cost to enclose the field with fencing. And we're given that the long side of the rectangle is 42 yards. The short side is 28 yards. We find the perimeter of the rectangle in yards. The perimeter is equal to 2 times the length plus 2 times the width. So when we substitute our values we know into this formula, we get 140 yards. The tricky part here is the fencing is priced per foot, and we found the perimeter in yards, so we have to convert to feet. There are 3 feet in a yard, so we find that 140 yards is equal to 140 yards over 1 times 3 feet over 1 yard. So that, or just simply multiply the 140 by 3, and that gives us 420 feet. So that is the perimeter of this area in feet. We multiply by the cost per foot, which gives us $2,205. Example 2, the sum of the measures of a polygon's angles. The sum of the measures of the angles of a polygon with n sides is n minus 2, all times 180. We want to find the sum of the measures of the angles of an octagon. Well, by definition, an octagon has 8 sides. This is going to be a regular octagon. So n is equal to 8. We substitute into the formula 8 minus 2 times 180. Do the inside first. 8 minus 2 is 6. 6 times 180 is 1,080 degrees. So that is the sum of the measures of the angles of the octagon. Finally, tessellations. These are just kind of an interesting thing to know. This is also called tiling, and some artists use it to develop their art pieces. A pattern consisting of the repeated use of the same geometric figures to completely cover a plane, leaving no gaps and there's no overlaps. The sum of the measures of the angles that come together at each vertex is always 360 degrees, a complete rotation. And the most restrictive condition in creating tessellations is that just one type of regular polygon may be used. That's the most restrictive. So here are some examples of tessellations. And in example 3, we want to explain why a tessellation cannot be created using only regular pentagons. We're going to use that formula that we just saw, n minus 2 all times 180, to find the measure of each angle of a regular pentagon. So substituting in, we see that each angle would have to be 180. Well, 180 plus 180 plus 180 leaves a 36-inch gap that you cannot fill with another 180 pentagon. So that shows us that we cannot use regular pentagons for the tessellation. And that completes this section.